This is the final example now on hypothesis testing with discrete distributions, and we are dealing this time with accidents that occur at an average of 6 accidents a month. We've called this going to be road accidents that happen somewhere. The council weren't very happy, so the council put up new signs. And then, after the signs went up, in the next month, there were 3 accidents. What we are trying to establish is, have the new signs lowered the rate of accidents, lowered the accident rate? So that is a summary of the question. We'll worry about that in a minute. Okay? So accidents occurring at an average rate of 6 a month historically. New signs are put up. In the next month, 3 accidents occur. Is there any evidence that the new signs have lowered the accident rate? The very first line up there, what is the very first line suggesting to you? Poisson, yes. The average rate should be suggesting that we are using the Poisson. So let's define a variable. X is going to be the number of accidents a month, and we will say that X is going to be Poisson at 6 a month. That's under the null hypothesis. So our null hypothesis is going to be that, lambda is 6. Our alternative hypothesis is that, well, said new signs had lowered the accident rate. So what will a less than 6? Okay, so we're doing a one-tailed test. So what will we do what calculations do we need to do to decide whether or not these have made a difference? Well, we will have to decide in a minute on something, but I don't want to go down the level of significance first of all. I'm just saying, first of all, what calculation will we actually be doing here? Yeah?
We want to turn it into the normal distribution. Is that what we want to do?
Is there a need to? Not if lambda's that small. There's no need to. You could, if lambda was big and met the criteria, you could do it. What would you have to remember in doing that? Yes, that's right. If you went from Poisson to normal, you'd have to remember the continuity correction, yeah. We don't have to do it here. But what calculation are we going to do? What's our test statistic, if you like? What are we going to do? Think back to how we were doing these last time.
Probability of 6 a month, 3 happening under the original conditions.
Nearly perfectly right. You've just said find the probability of 3 happening in a month under the conditions of H0. Nearly right. Just need to maybe put a few extra. Yeah, 3 or less than. 3 or basically more extreme than that. So 3 or less than. Yeah. So what we need, the statistic that we need, is we need the probability that X is 3 or more extreme than 3, which here is lower than 3. So that is what we want.
What is the significance then?
We haven't actually said that yet. Rob's asked for it 3 times and I've refused to give it to him so far. Okay. So we'll see what probability we're going to get here, and it may just be blindingly obvious. I mean, if it comes out as being 0.0000001, well, who cares what the significance level is? I mean, we're going to reject H0 anyway, aren't we? So you need to do this. It's either tables or it's writing out formally and adding up, or if you know what you're doing on your calculator, just going to your calculator. Okay, so we've just heard it's quicker to use a tables than a calculator. I agree. Poisson 6, less than or equal to 3. I reckon you can just read that number off. Okay, plus on 6, less than or equal to 3, 0.1512. Great. So, we do need a significance level, okay? Generally, no, Rob, yeah, you're right, Greg, yeah. If we say we were going to use the 5% significance level, say that we'll use a 5% significance level, what would we conclude here?
It's greater than 5%, so we accept H0.
Yeah, we have here our probability is greater than our significance level, so we would accept H0. In other words, we've said there's a 15% chance. Yeah, sorry. There's a 15% chance this could have happened without any change to the signs anyway, under the null hypothesis. So it's definitely not significant. So we'll accept H0, that lambda is still 6, and we will therefore reject H1. So that means there is no evidence, and try and get into the habit of writing the sentence at the end. There is no evidence at the 5% significance level the new signage, I like the word signage, I'll write signs if you like, the new signs have reduced the accident rate.
This is an bad example, though. You wouldn't really do more tests. So continually free and
6 per month.
Yes.
Every time in 6 months.
Yeah, but looking at that,
With some, it's going to be independent in different months. You're getting more accidents, like with ice and what.
Yeah, there could be. Yeah, I mean, this is quite limited here because of the numbers. I agree. Okay.
any of the questions that aren't really that good. They succeeded somehow.
At A level, you are given problems which are made simple and non-problematic, certainly to a certain extent, and a lot of the real life problems that you actually would come across are removed from the scenarios. If you go to university, that's when you start dealing with more complicated things, and the most complicated thing is real life to a certain extent, yes, and what actually happens. So we've said here, okay, at the 5% level, no significance. But let's just pose the next question, like a follow-on question here, and to say, what rate of observed accidents in this next month would we have had to have seen to conclude that the signs did make a difference? So the sort of follow-on question here is, how many, or should we say how few might be a better word there, how few accidents in the next month would have suggested the signs worked? It's not the best sentence, but I think we know what's going on. Basically, how many accidents would have had to have fallen to convince us at the 5% significance level? So, how should we go about answering that question? Yeah?
Probabilities like less than some critical value, and then so
Pretty much, yes. We will look at probabilities. So we go back to your tables is the easiest thing to do. Look at your tables for lambda equals 6, and look here. We want something, well, we want the biggest number which is below our significance level. What is the biggest probability here smaller than 5%? It's that one there. Yes. So if we sort of do an extract from the tables, we've got when x is 1, the probability is, find the right one, 0.0174. When x is 2, the probability was 0.0620, and these are less than or equal to, so I really ought to put there. Our 5% level is here, between those two, so we would only have rejected H0 at the 5% level if there had been one or fewer accidents. So the answer to that question is one or fewer accidents. And we looked there, I'll write it down in case anybody wants it for the notes or completeness. What we did is we looked for the largest probability that was less than our significance level, and then the x value associated with that probability, that was what sorted that out for us. That's the end of the examples for discrete hypothesis testing.